Mhm. You remember your algebra 1, remember when you learned that 3 times 3 was 3 squared. And obviously, if you have x times x, you have x squared. So the square of a number is something you learn in algebra 1, possibly earlier than, and the exponential the same. Then you define this as an operation, the square of a number. Once you have a new operation, you remember that you get the inverse operation. So you have the square root of x. The square root is a number such that if you square the number, you get the x, correct? So this is the relationship of this one. So in algebra 1, you learn to solve the questions involving squares. So for instance, x squared minus 9 equals 0 was something you were able to solve. So you put x squared equals 9, and then you use the inverse operation, the square root. So you square root x squared, the square root of 9, and then these two cancels, you get the x, and then you know that the square root of 9 is positive and negative 3. So you have two solutions. So pretty much this is what you have. When you introduce a new operations, you may have equations involving that new operation, and then you can solve this equation, correct? Same is going to happen with calculus, and this is the next topic we are going to cover. For instance, you have dy dx equals 3x squared minus 1, for instance. It's okay. This means that the derivative of y respect x is 3x squared minus 1. So here the y is a function of x, correct? Y is a function of x. And then my question is, okay, this is the derivative of y, but whose y? So what function gives me that? It's okay, this is, well, the derivative is an operation, and then you know that the derivative is the inverse operation of the integral, correct? Integral dx, right? So if you have a derivative, the inverse is the integral. If you have an integral, the inverse is the derivative. So it's exactly what you're going to do, same as when you have that the square and the square root were inverse operations, correct? The square and the square root were inverse operations. So you know that you can undo one with the other one. So in this case, the function is inside a derivative, so I have to undo the derivative. So to undo the derivative, I have to use the integral. So I take integral dy dx is the integral 3x squared minus 1, correct? Dx. So you see, same as I do this one in algebra 1, square or square root, I apply the integral both sides. Then this integral, right, is going to cancel out. So you have the integral of dy is like these two cancels, dx with dx. And then you have here the antiderivative. What is the antiderivative of 3x squared? Well, it's x cubed. What is the antiderivative of 1? Well, it's x. Then remember that the antiderivative has a constant. So this constant, the derivative of this constant is 0, so much with this one. And then this and this cancel, so you have y equals x cubed minus x plus c. So this is the solution of this equation, right? Of course, because you have here a constant, right? You have many solutions, correct? So you have to specify where your function passed through, or you have to specify a point, correct? So let me just suppose that you know that y of 0 is 1. So this is a condition. So you know that y equals x cubed minus x plus c, right? Then you know that y of 0 is 1. So you put a 0 right here. So you have 1 cubed, no, 0 cubed minus 0 plus c equals 1. And you immediately solve that the c equals 1. So my solution is going to be x cubed minus x equals plus 1, correct? So that's the solution of this equation. This, because has a derivative, is going to be known as a differential equation. Okay? So this is the new thing you are going to learn. And those ones pursuing an engineering career, right? Everything you are going to solve in engineering, at least 99.9% of the cases, is going to be a differential equation. It's very important you catch this. So you want to be an engineer? Well, you are going to model your problems with differential equations, with derivatives. So if you want the solution, you will have to solve differential equations. So you are going to use the most difficult procedure in calculus, integration. Remember that integration is a pain, correct? So that's what you have to do when you have differential equations, integration, right? Then, of course, you have specific values for your function. This is something you have to know in advance. And then you determine a unique function. In this case, you don't put any condition, you have many solutions. So everybody catch the idea what is going to happen in this unit? I'm not going to do the easy ones because it's just basic integration. I'm assuming you do that. What I'm going to do is the first topic related with differential equations, and it's pretty much right here. Let me just use the assignment right here, okay? Right here. So this is the first problem in your assignment. You have a differential equation, and this differential equation, right, has x and y's, is implicit. So you have the y that is right here in the derivative, also with the x. So what's going on in this case? This is, well, in this case, what I'm going to try to sketch is what is called the slope field. Remember, dy dx is the slope of the tangent lines for this function y. So one of the first approach we are going to do in this unit is draft the slope field, so the directions of the tangents for this differential equation. This is going to be not difficult, it's going to be something sometimes annoying because you have to do some operations, but everything is going to rely on your concept of a slope, correct? You know, the slope is the slant of a line. So you know different slopes that are classical. For instance, if you have a slope 0, that's a horizontal line, so like this segment. If you have, for instance, a slope of 1 or 45 degrees, right? 45, you know that pretty much the slope is like this one. Then if you have, for instance, a slope of 90 or undefined 90 degrees, you know that that's the vertical, correct? Then you know that if you have slope -1, right? The slope is in this direction, correct? Now, if you want to represent any slope, for instance, 2, okay, you know that 2 is steeper than this, so you pretty much can represent this. And if you want slope 3, this is, well, is a little bit steeper, right? And if you want 4, even more steeper, correct? So you know that the slope increases as the value of the slope increases. Same if you want -2, so you have something like this, more than this. You want -3, you have something like this, even more. And if you have -4, it's practically vertical, right? So these are going to be approximations we're going to use to graph a slope field. So everybody catch these first four, yeah? Horizontal 1, vertical -1. Then everything else is more than this and less than this one, correct? So 2 is more than this, it's steeper. 3 is steeper, 4 is more. -2 is steeper than -1, -3 is more than -2, and so on. So it's exactly what is going to happen. So this is going to be the code to break these problems. So let me just go here and graph this problem again. So I have to graph the slope field for this differential equation. And then I have to sketch the solution when the equation passes the point 1, -2. Okay? How do you solve this one? It says, well, is very simple. You are going to evaluate the slope at these points. So this point, right here, this point is 0, 0, correct? So this is 0, 0. This is 1, 0. Let me just use a pen, much better. Let me just use a marker, this marker. That is better. So 0, 0. So this is the point 0, 0. This is the point 1, 0. This is the point 2, 0. This is the point 3, 0. So basic coordinates, correct? This point right here is the point 1, 1. This point right here is 2, 1. This point right here is 3, 1. This point right here is 1, 2. This point right here is 1, 3, and so on. So no problem with the coordinates. For instance, this point is 1, -2. So everybody catch this? So these points have coordinates and all of them are integers. So for instance, this one is -1, 0. I think you don't have problem with that, correct? So what I'm going to do is very simple. So I'm going to use these values from the grid right here. So for instance, here for this point right here at the origin, the x is 0, the y is 0. So dy dx is 0 plus 0. So dy dx is 0. How do you represent that one? This is, well, that is, let me just use a different color, a red one. Yeah, you are going to represent as a horizontal segment, correct? So in this point, in the point 0, 0, the slope is 0 plus 0. So the slope is 0. What about in 1? Okay, in 1, 0, the x is 1, the y is 0. So the slope of this differential equation at the point 1, 0 is 1 plus 0. And 1 plus 0 is 1. So I'm going to represent my 1 slope with this one. Remember my convention, right? Okay. This is 2, 0, 0.20. How's the slope of this derivative in 2, 0? Well, the x is 2, the y is 0. So you put here 2 plus 0. 2 plus 0 is 2. So you're going to put a steeper line, correct? Representing the 2. What about here? Okay, here is 3, 0 point. The slope right here is 3 plus 0. 3 plus 0. 3 plus 0 is 3. So you're going to have a steeper line. You see? Now, the same reasoning is going to happen, for instance, for the y's. This is the point, right? This is the point 0, 1, right? So for this point, x is 0, y is 1. So this is 0 plus 1. That's a 1, so the derivative is 1. So I'm going to put something parallel to this, right? Now, this is the point 0, 2. So the slope here is 0 plus 2, 2. So I'm going to try something parallel to this line. So something like this. And obviously here is 3, 0, 3. So this is 0 plus 3. The derivative, the slope of the tangent line is 0 plus 3, 3. So it's going to be like parallel to this one. So I'm going to put here something like this, correct? Now I'm going to do this axis, right? Okay, this is the point 0, -1, correct? This is the point 0, -1, okay? X and Y. So the slope of this derivative, right, of the slope in this slope field for this point is 0 plus -1, 0 plus -1, right? That's -1. So I'm going to use the -1. So I'm going to represent this something like that, correct? That's a -1 slope. The next point again, this is 0, -2. What is the slope right there? 0 plus -2, -2. So something steeper in the negative direction. And this is the point 0, -3. So this is 0 plus -3, -3. So this is like this, correct? Okay. Same is going to happen in this direction. This is the point negative 1, 0. So the slope right here in this point is negative 1 plus 0, negative 1. So I'm going to have here negative 1. This is negative 2, 0. Well, I do the same operation. This is going to be negative 2, and this is going to be negative 3, correct? Yep. Now, what happened in these points? Well, if you see, there are paths. This is 1 plus 0. Here is 1 plus 1, 1 plus 2, 1 plus 3. So here is 2, 3, and 4. So I'm going to do only 2, 3, 4, correct? This is 2, 0, 2, 1, 2, 2, 2, 3. So here is 2 plus 1, 2 plus 2, 2 plus 3. So this is 3, 4, 5. So you go with the steeper slopes, correct? Here is 3 plus 0. This is 3, 1, 3, 2, 3, 3. 3 plus 1, 3 plus 2, 3 plus 3. So this is 4, 5, 6, correct? Same is going to happen in all these points. This is negative 1, negative 1, correct? So 1 plus negative 1 is 0, okay? You put a 0 here. This is the point 2, negative 2. 2 plus negative 2 is 0. So all this line is going to have a 0. So if you see this line, okay, all these ones are going to be 0. So I'm going to put here 0, 0, 0. You see? 0, 0, 0. Okay? Now, you can see like animation. It's something that is falling and is rotating. So 4, 3, 2, 1, 0. What is the next number? Negative 1. So all this line is going to be negative 1, you see? So I'm going to put here negative 1, right? Then check, this is 3, 2, 1, 0, negative 1. This is 3, 2, 1, 0. You see the slope, the sequence of the slope? 3, 2, 1, 0. So let me see, 2, 1, 0. And then I can do the same here. So for instance, you have negative here, you know this is a 1, right? 1, 2, 1. And then for instance, negative 1, this is going to be negative 2, negative 3, negative 4. Negative 2, negative 3, negative 4. This is negative 2. This is 0, negative 1, negative 2, negative 3, negative 4, negative 5. This is 0, negative 1. This is going to be negative 2. Okay, negative 2, negative 3, negative 4, negative 5, negative 6. So there is the slope field for this differential equation. Now, this is going to give me the directions of the tangent lines. Now, here is the situation. I need to find the solution for this point. This is the point negative 1, 2, right? Yeah, no, 2, negative 1, sorry. This is the point 2, negative 1. That's it. This is the point 2, negative 1. So I have to locate the point 2, negative 1. So this is 2, negative 1 right here. This is the point 2, negative 1. This is 2, negative 1. It's right here. This is the point, correct? So here, my function, my solution has to touch this point. So let me just use a different color. For instance, the blue, what is the blue? Or the green, this one, right? So my function has to pass right here, correct? Now, the function has to follow the direction of the slope. Suppose this is a freeway and these are the sides, the concrete sides. So they cannot cross like this. So they have to follow the sides, something like this, correct? Then this one is a wall, so this cannot cross in this direction, so cannot cross the walls. So it has to turn something like this, right? And then follow the direction. So this is going to be pretty much the representation of the solution for this differential equation passing in the point 2, negative 1. This is the point 2, negative 1. Once you have the directions, it's okay, this is the point. So the slopes goes in this direction, so the curve has to go in this direction. And in this other one cannot cross like this one, is like crash to wall. So you have to follow the wall, right? So it's going to be asymptotic to that line. Okay, everybody? Questions here? Any point not clear? No, really? David, Luis, is
Todo bien.
here? Yeah? Voy a hacer otro ejemplo. I'm going to do another example. So, everything clear here? Bueno, let me just take another example right here. All right, what is it? Oh, I was supposed to have another one. Oops. No. Okay. Let's see. No. This one. Aquí está. There it is. Here is the other example, correct? This is going to be pretty simpler. Really, this is the first example, right? I began with the second one. Okay, it's the same. dy dx equals x. Okay. Now, the first thing I have to remember the coordinates of this point. It's implicit. 0, 0, 1, 0, 1, 2, no. 0, 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2, 0, negative 3, 0, 1, 1, 2, 2, 3, 3. So no problem to get the coordinates. This is 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2, 0, negative 3, and so on, correct? Okay, let's see. Let me just begin with the axes. Those are the easy ones, correct? So here is the point 1, 0. X is 1, y is 0. So I have to take here x. Well, the x here is 1, so dy dx equals 1. So my slope is going to be 1. Here, the coordinate x is 2. Okay, 2. Here, the x coordinate is 3. The y is 0, but there is no y here. So I'm going to put something more vertical. So 1, 2, 3. Now, here is 0, so here is horizontal, right? Now, you see the pattern? Here is negative 1, x, y 0. So this is going to be negative 1. So I'm going to put negative 1. This is negative 2, 0. So here is negative 2 and negative 3. So you see the sequence? Okay, now, what is going to happen in this line? Okay, in this line, the x is always 0. This is 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2, 0, negative 3. And this equation is just taking the x. So in all this portion, the slope is 0 because the x is 0. So I put a 0, 0, 0 slope, a little segment with 0 slope. Okay, now, in all this line, the x is 1. This is 1, 1. This is 1, 2. This is 1, 3. 1, negative 1. 1, negative 2. 1, negative 3. So for all these ones, the x is 1 and is the only component I'm going to take here. So right here, all the slopes are 1s, correct? 1, 1, 1. Here, all the x coordinates are 2. 2, 1, 2, 2, 2, 3, 2, negative 1, 2, negative 2, 2, negative 3. So for this equation, all these slopes are going to be 2. So I put here 2, 2, 2, 2, 2, and 2, correct? All this line is going to be what? 3. 3, 1, 3, 2, 3, 3. So all the slopes here are going to be 3. So I'm going to try to do parallels to this one, right? This represents a 3. And I finished the right side of my graph. Okay, let me just do the left side. Well, it's going to be the same reasoning. For all this line, x is negative 1. For all this line, x is negative 2. For all this line, x is negative 3. So in all this line, I'm going to have negative 1s, correct? And this is negative 2, so it's going to be more vertical, right? And here is negative 3. Okay, more, 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 and more. Okay, now, this is my slope field, correct? for this equation. Now, I need the solution passing in 1, 2. So for x equals 1, no, for x equals 2, y equals 1. So this is the point 2, comma 1, correct? For x equals 2, y equals 1. So I have to locate the point 2, comma 1. So this is 1, 2, 1 is right here. That's the point, correct? Now I'm going to sketch pretty much a graph, correct? So the function has to go tangent here, and then obviously has to continue because has to follow the slope field. And right here looks like has to turn, you see, has to turn, and is going to do possibly something like this. So I'm going to do that. And then right here, I have to pass pretty much like this in that direction, correct? Now, is this consistent with this equation? Well, if we solve, we are going to see something. dy dx equals x, correct? So we integrate dy dx equals the integral x dx, correct? And then, well, this is going to be integral of dy equals, antiderivative of this is x squared over 2 plus c. This is going to be y equals x squared over 2 plus z. And then you put here your coordinate, this one, right? This is, well, let me see. For x equals 2, y equals 1. So I have 1 equals 2 squared over 2 squared over 2 plus c. And if you solve, you have here 2c. So c is -1, correct? So my solution is going to be y equals x squared over 2 minus 1. This is a parabola, correct? Well, you see here a parabola. Catch it? This is a sketch of the solution. Okay? So everybody's catching the idea of the slope fields? Well, I don't think I need another explanation, right? The examples are pretty clear?
Yes, sir.
Yes, sir. What happened? Okay. Everything fine? Okay.
Yeah, everything's fine.
Yep.
Okay. So problems like these are going to be in the homework. Remember, your homework is this one right here, is right here. So you have to do pretty much the same thing, correct? It's going to be, well, takes a while, but it's not difficult, right? Then we are going to do now with the calculator. The calculator is able to do this. So it's able to display something like this. I'm going to show you that. So I'm going to now go to my second part of my assignment. So is this one? No, it's not this one. Is this one right here. So you have two differential equations. I'm going to annotate my differential equations. dy dx equals -x over y, and dy dx equals 0.5y, correct? So let me just put this one also, dy dx equals x to begin with, right? So let me just now work these three differential equations. Let me just begin with this one, the one we got the solution, you see, this one, okay? So with the calculator, let me just take here the calculator, and you see the calculator. Now you have to add the graph. So you click here in graph, and then you are familiar with this thing. So it's the graphing window. Here you can graph a function, but you don't want a function, you want a differential equation. So you have to click on menu, right? Uses graph entry, and then you see here at the bottom diff-ec, differential equation, correct? So this is going to be your entry. You click, and then you are going to have here a different format. Okay, so This is y1, so y1 prime. This doesn't look, but this is a prime, correct? So my differential equation, right, for the calculator is going to be 1y prime, yep, equals x. So let me show you the paper, the board. So I want dy dx, well, remember the notation, dy dx is also y prime, but for the calculator, the y for this entry is going to be y1. So you see y prime equals, and then in this side, you are going to write the value of the derivative of the differential equation. So you are going to see this one, right? So y1 prime equals x. So you are going to put the x. Click. Then you are going to press enter, right? And you are going to see the slope field. Okay? If you see that one and you compare with this one, it's pretty much similar, right? Correct? It's very similar. It's the same one, except that there is a different scale. This is 1, 2, 3, and here the calculator put its own scale, correct? I don't remember, we can just settings, no, right here, Windows on, Windows settings. Here is auto. Let me see if we do ones and we scale 1, right? Yeah. No, it doesn't take it, right? So the calculator do its own scale for the differential equation. Now, remember that we plot here the solution passing in 2, 1. You see that? Okay. I'm going to plot the same equation. So I'm going to my calculator again, and then in Control G, right, I go up and I see my first entry, y1 prime equals x. Now here I'm going to put the point. This is the point 2, 1, so I'm going to put here 2, 1, right? And then I press enter, and I'm going to see the graph passing in 2, 1. Here is the point 2, 1, you see? So it's exactly what you sketch by hand. Well, pretty much, right? Everybody clear how you use the calculator to do this graphing?
Yep.
Okay. Yes, sir. No problem? Piece of
No.
cake?
Nada, sí, sí.
Okay, bueno, vamos a ver. Let me just now do the second one, correct? The second problem with it. This one. I'm going to reproduce this slope field and see if I'm correct. So now is dy dx is x plus y. Okay. Now, let me just go back again to my calculator. And usually what I do is use a new document. I don't save, and I enter the graph. Why? Because what I have seen is it keeps something in the memory. If you do the first graph, everything is going to be linked to that one. So I usually begin a new document for a new differential equation. So I have an f1 of x. So I again do graph n3, differential equations, and then I'm going to put x plus y. Remember, this is the y. So if I put x plus and y, I'm not going to see anything. Why? Because this y is here. This y is not this y right here. This is y1. So here you have to put y1. Okay? Then you press enter, and then you see the slope field. You see, you remember this one. It's pretty much the one we sketch, right? And now we're going to do this solution passing into comma -1. So you know what to do. You go to the entry right here, then you see Control G, then I move up, and then here I'm going to put 2, and here -1. I press enter, and I see the solution, right? The solution passing into -1. That is pretty much what we sketch right here on my paper. Okay? So the slope fields are very, very simple, really. So not a big deal, correct? Now, if you want to do any of these two, if you have a calculator, I don't know you have one, but let me just try this one, dy dx equals negative x over y. Okay, so I have my calculator, right? Again, I'm going to do a new graph, new document. I don't save, graph, menu, entry, differential equations. And then I'm going to put negative x over, remember the y here is y1, so you have y1. Then you press enter, and then you're going to see the slope field. A circular slope field. Very nice, right? Let's suppose you want the 0.5y. Okay. Menu. I'm going to do a new document, right? I don't save. Add the graphs. And then I use differential equations, right? Graph N3, differential equation. And then I put 0.5y. Okay. 0.5 times y. Y1, let me see, here is y1. It's very important you put the times, okay? y1. Press enter, and then you get your slope field. Now, if you check your assignment, right? You check your assignment right here, you can identify the slope fields. You see the same ones? So you have to identify that this is for B and this is for A. Correct? So not a big deal. Okay. This problem is from an AP test, correct? It's a differential equations problem. Let's see how much of this we can do now, correct? So this is by hand. So I'm going to have here a grid, right? And I'm going to write here at the side, yeah, the problem. Let me just take this one. Okay, I have here the problem now. Let me just stop share. And I'm going to put here a grid. I have a grid. If you have your assignment, you have the same grid. The problem with the grid right here is very small, right? So I prefer to work in a larger grid. So my equation, my differential equation is simply dy dx equals x over y, okay? And then you have, on the x's provided, sketch the corresponding slope field. Okay, not a big deal. Remember that these are the coordinates of these points. So let me just begin for the coordinates where, right, this axis, this is 1, 0, 0. This is undefined, so I have nothing here. This is going to be 0 over 0, so nothing. This is 1, 0, so this is going to be 1 over 0. This is 2, 0. This is going to be 2 over 0. This is 3, 0. 3 over 0. You know what is that? It's the vertical line. So here I have a vertical, vertical, vertical. Here is the same, negative 1, 0, negative 2, 0, negative 3, 0. So it's going to be over 0. So I have verticals, correct? Right? Okay. Now, in the vertical, these coordinates are 0, y. 0, 1, 0, 2, 0, 3, 0, negative 1, 0, negative 2, 0, negative 3. So you are going to have 0 over a number, except this one that is 0 over 0. So 0 over any number is a 0. So you know here that the slope is going to be 0 for all these ones, right? Okay, now let's suppose you have this axis. This axis is 1, 1, 2, 2, 3, 3, negative 1, negative 1, negative 2, negative 2, negative 3, negative 3. So these two are equal, and when you divide two equal numbers, you get a 1. So in all this field, the slope is going to be 1. So you have 1, 1, 1, 1, 1, and 1, correct? what is going to happen in this line? This is -1, 1, -2, 2, -3, 3, 1, -1, 2, -2, 3, -3. So what is going to be here? The slope, well, is a positive number divided by its negative number, right? So that's a -1. So I'm going to have a -1. So I'm going to put here -1, -1, -1, -1, -1, correct? Okay, now I have to figure out how is going to be here the slope. Okay, let's see here. In this point, this is the point 1, 2, correct? This is the point 1, 2. Okay, so is 1 over 2, 1 over 2. So it's 0.5. So is going to be 0.5. This is 1, so 0.5 is going to be something like this, less slope. This is the point 1, 3. Okay, so this slope is going to be 1/3. So it's less than this one, so it's more horizontal, correct? Now this, right, is going to be, this is the point 2, 3. So this is 2/3. So this is a little bit than this, little bit more than this. So this is going to be like that, right? Now, what is going to happen here? Okay, here, this is going to be 2, 1. So this is 2 over 1, right? 2 over 1. So is more, right? So this is 1, 2 has to be something like that. This is going to be 3 over 1, because this is the point. This is the point 3, 1, right? So this is the point 3, 1. So it's going to be 1 over 3, or must be 3 over 1. So this is steeper. So this is going to be like this, correct? You see that? So you see the behavior of the slope field is going to be something like this. So pretty much you can predict what is going to happen here. So you don't have really to break your neck doing this one. So it's going to be like similar like this, right? And like this, right? And like this. Something like this, correct? And what about this side? Okay, this side looks the same pattern, right? So I'm going to have something symmetric like this and something symmetric like this, correct? And then you can pretty much guess this one. What do you think is going to happen here? Well, pretty much the same as here. So this is going to be something like this. So it's going to be pretty much something like this, right? Yep. And here at the bottom, yes, it's okay. You see the pattern. So you see that it's doing this. The function is doing this, is doing this, is doing this curve. So pretty much here is going to happen something similar, right? Remember, this is a sketch. So this is my slope field for this problem. dy dx, dy over x, dy dx equals x over y. Is this one, correct? So you don't have really to do the calculations of everything because you can see patterns, correct? So yes, possibly you have to do lines as the axis and 1, 1, this line and this line. And then you can pretty much figure out what happened between them, correct? Okay, any question in this point? This on the axis provided, sketch the corresponding slope field. Well, it's here. Second one, on the slope field, sketch a solution curve that passes through the point 0, 1. Okay. What is the point 0, 1? 0, 1 is this, okay, solution. So I have to do, this is A. Oh, this is A, slope field.
Hey, Ramirez, I have to go and I can't go to the 12 o'clock one.
No problem. Okay.
Tomorrow. Bye.
Okay. Now, the slope field is a solution y of 0 equals 1. So this is the solution I want. So it's in the point 0, 1, right? So, well, that's not difficult. What is the point 0, 1? 0, 1 is right here. That's my point. So my solution has to touch this point right here, yeah? And we have to follow only the slope field. So, well, it looks like it's going to do something like this, right? Cannot cross in this direction. And in the other side, you're going to do pretty much the same, right? So that is pretty much the sketch of the solution passing in 0, 1. Next question, this Z. Find the particular solution of the differential equation with the initial condition f of 0, 1. Okay, this is going to be something we're going to solve later. On the slope field, sketch a new solution passing now in 0, negative 1. Okay, let me just skip C. We're going to solve that next class, next week, right? This is D, right? On the slope field, sketch a new solution curve passes that now do this is Y in 0 is negative 1. So passing in 0, negative 1. So that's the solution I want. So, okay, that's not a problem. So 0, negative 1 is right here. So we don't have to really suffer too much to sketch a solution. So the solution is tangent right here, and then has to follow the direction. So I have to do this, and then it has to do this, correct? That's the other solution, right? And E, find a particular solution. It's okay, E, find a particular solution. Let me just put it right here. The C, D is E. This is find a particular solution. So when we're going to leave this open for the next one. So we're going to solve this one analytically next class, correct? Right now, I don't want to bomb you too much with too much things. So I'm expecting you catch this concept, right? Any question?